When it comes to factoring, we often encounter special cases in which we could quickly solve or quickly factor an expression by using a few simple special rules. One of these special rules that allow us to easily factor an expression is a difference of two squares. Now this occurs when you have a squared minus b squared. A is a perfect square and b is a perfect square. So if you have a difference of two squares, you could quickly factorize them to be a minus b times a plus b. So if you remember this, or if you understand this formula, then whenever you have something that's a difference, or when you're subtracting two perfect squares, you could just write them as a product containing a minus b and a plus b. Let's have a look at an example so that we could really drive this point home. Let's say we had 9x squared minus 4. Now 9x squared is a perfect square, and so is 4. So we could also write it as, we could write 9x squared as 3x all squared, and we could write 4 as 2 all squared. So you could see now that we have the structure of a squared minus b squared that we could use to our favor, and we can see that a in this case is 3x and b in this case is minus 2. So all we need to do now is just plug it into that equation and move on from there. So that gives us 3x minus 2 times 3x plus 2. Remember, this expression here just represents a minus b times a plus b, where 3x is a and 2 is b. So that's how a difference of two squares works. It's one of those special cases that you just need to identify and use this formula right here. Again, 3x is equal to a in this case and b is equal to 2 in this case. So when it comes to these special types of factoring situations, it's all about identifying what's a and what's b, and nicely and neatly plugging a and b into the formula for that situation. Another type of special case that we often encounter in factoring is factoring perfect square trinomials. That occurs when we have something like a squared plus 2ab plus b squared. Now if you have a trinomial like this, where there's a perfect square at the start and a perfect square at the end, and you could write the center term as 2 times those terms, then you could use the special case formula and you could write it as a plus b all squared. Again, here the idea is still the same. You're really just looking to identify what a and b is and neatly plug it into this formula. So let's look at an example to get a better understanding. But before we do that, remember that a plus b all squared is just another way of writing a plus b times a plus b. So let's look at an example at this point. Let's say we had 16x squared plus 24x plus 9. If we look at this expression, we notice that the first term here is a perfect square and the last term here is also a perfect square. So now the only thing is we have to figure out is, can we write this as 2a times b? So let's go on to identify a and b. So we could write 16x squared as 4x all squared. Let's quickly ignore the middle term, and we can write the last term as 3x squared. So look, comparing this expression that we have here to what we have in this formula, we could say that a squared is 4x squared and b squared is 3 squared. So a would be 4x and b would be 3. So we write that down, 4x all squared, and we try to see if this middle term here will give us 24. Can we write 24 as 2a in this case is 4x and b in this case is 3, and the last term would be 3x squared. So we notice that this here will give us 24. If we multiply 3 times 4, that would give us 12, and 12 times 2 will give us 24. So this fits a perfect square trinomial perfectly. So this is a perfect square trinomial. So therefore, we could just write it as a plus b all squared. Remembering that 4x is a and 3 is, so the factors would be 4x plus 3 all squared. Again, a in this case was 4x and b in this case was 3, and all we did was plug that into that equation. and we got 4x plus 3 all squared, which is the same as writing a plus b all squared. Sticking with the theme of perfect square trinomials, there's another perfect square trinomial that we often find, which is of the form a squared minus 2ab plus b squared. Now the difference between this and the previous case is that the second term here, this minus 2b term, or this 2b term, has a negative sign. So that's the only difference, and the formula for solving this also has a negative sign. When you solve it, you also have a negative sign. So you have a squared minus 2ab plus b squared. So you look for a trinomial of this form, and it's similar to what we had in the previous case, but now the difference here is that we have a minus b all squared. So again, the idea is similar. You find a trinomial where the first term is a perfect square and the last term is a perfect square, and you have to make sure that the center term is 2 times a times b. And if you find that structure, you could just identify a and b, and to factorize that, you have a minus b all squared. Let's take a look at an example such as 36x squared minus 60x plus 25. This first term, 36 is a perfect square, x squared is a perfect square, and so is 25. So it's encouraging that this looks like something of that form, where a squared plus b squared. And now we need to make sure that the middle term is equal to minus 2ab. So we could write 36x squared as 6x all squared. We'll gloss over the 60 for now, 60x for now, and we could write 25 as 5x squared. Now we can see that a is 6x and b is 5. So the question is, can we write 60 in a way that reflects the middle term here? So we have 6x all squared minus 2 times a, which is 6x. If we multiply all these factors here, we get 6 times 5 gives us 30, 30 times 2 gives us 60. So this means that we can use this perfect square trinomial formula. So all we have to do is identify that that's a and that's b and stick it in there into that formula. So to factorize 36x squared minus 60x plus 25, all you have to do is write it as 60x minus 5 all squared. Again, in this case, we notice that a is equal to 6x and b is equal to 5. Another special case we often find is a sum of 2 cubes. So if you have 2 cubic terms, a cubed plus b cubed, we could just write it as a plus b times a squared minus ab plus b squared. So it's just a function of noticing that we have 2 terms that are cubic terms, and identifying a and b and plugging a and b into this formula. So let's go through that. So we had x cubed plus 27. Now we could write x cubed plus 27. We could write x as x cubed or x all cubed, just to simplify things. And we could write 3 cubed as a representative of 27. So 27 can be written as 3 all cubed. Now if we write it like this, we notice that x is equal to a in this case and 3 is equal to b in this case. So it's just a matter of plugging x and 3 into this equation here. So to factorize x cubed plus 27, we could write it as x plus 3, which is analogous to a plus b, times x squared minus 3x plus 9. So here this is a plus b, and we identified that x is a and 3 is b, and this is x squared, which is the same as a squared in that equation, and this is minus 3x, which is the same as minus ab plus b squared, which is the same as 9, which comes from squaring 3. So that's how a sum of 2 cubes works. Again, all we had to do here was identify a is equal to x and identify b is equal to 3, and then we merely plugged x and 3 into that equation. So it's important to learn the structure of these equations. Notice that in this case there was a plus sign this and there's a plus sign there, and everything in here was positive except the middle term. Okay, let's do another sum of 2 cubes problem, which, remember, the equation looks like a cubed plus b cubed, which is equal to a plus b times a squared minus ab plus b squared. And if we had 64x cubed plus 8, we can write 64x cubed as 4x all cubed, because if you multiply 4 times 4 times 4, 4 by itself 3 times, we get 64, and if we multiply x by itself 3 times, we get x cubed. So the second term becomes 2 all cubed, because 2 times 2 gives us 4, and 4 times 2 gives us 8. So multiplying 2 by itself 3 times gives us 8. So we identify, so we see that now we have something that's analogous to this equation. So we have a, which would be 4x in this case, and b, which would be 2 in this case. So that would equal to, now it's just a matter of plugging a and b into the equation, and we would have 4x plus 2. So once we identify a and b, which is 4x and 2, we could plug it into that equation on top here, and we have 4x plus 2, which is the same as a plus b. And now we need to plug a and b into the second part of the equation here. So that would give us 16x squared, which comes from 4x all squared. 4 squared gives us 16, and x squared gives us x squared here, minus a, which is 4x written here, and b, which is 2 written here. So we have minus 2 times 4x, which is the same as minus a times b, and the last term becomes b squared, and b is 2 in this case, so 2 squared is 4. So let's just simplify this middle term. So we have 4x plus 2 times 16x squared minus 4 times 2 gives us 8, so we have minus 8x plus 4. So to factorize 64x cubed plus 8x, we have 4x plus 2 times 16x squared minus 8x plus 4. And all we had to do again was identify 4x as being equal to a, and identify b as being equal to 2, which we did in this step here, and we just merely plugged a and b into that equation above there. So another type of special case that we could find, or we often find, is when you have a difference of 2 cubes. So that's when we have a cubed minus b cubed. In such a case, you could use this formula here, where you say a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now it's all very similar to the previous situation, but the signs are different. So here in the first brackets we have a minus sign, so we have an a minus b, and here this sign is now positive. So let's take a look at an example. 27x cubed minus 8. 27 can be written as 3x all cubed, and 8 can be written as 2x cubed. So that means a is equal to 3x and b is equal to 2. Plugging a and b into this equation here gives us 3x minus 2, which is the same as a minus b, times 9 squared, which is the same as a squared. 3x squared is a squared in this case, so 3x squared gives us 9x squared, plus a times b. So a in this case is 3x, so we have 3x there, and b in this case is 2, so we have 2 there, and the last term is b squared, which is 2 squared, and that's why we have 4 there. Simplifying this middle term, we have 3x minus 2 times 9x squared plus 2 times 3, which gives us 6x plus 4. The main idea here was identifying 3x as being a and identifying b as being equal to 2, and plugging 3x and 2 into that equation over there. So that's it for factoring special cases. And if you find value in these types of videos, please like and subscribe so that we can do more. Thank you.